So in this case, what I'm going to do is, again, show you how to do P over Q and then find all the zeros. So the main important thing we want to do is first understand what P or Q is. P is going to represent our constant, and Q is going to represent our leading coefficient. Now, again, remember, the sign of them is not going to matter, because when we do the P over Q test, we're only going to be dealing with the factors and the positive, the minus, or the plus or minus of the factors of P over Q. So first thing we need to do is identify P and then identify all the factors of P. So P is 18. We identify all the factors. So it's going to be 18 times 1, 9 times 2, 6 times 3. And that's going to be it. Then we go and look at Q. We see the factors of Q are going to be 4, which are 4 times 1 and 2 times 2. So all the factors of P are going to be 18, 9, 6, 3, 2, 1. And all the factors of P, or Q, I'm sorry, will be 4, 2, and 1. Now, I know there's two factors of 2, but you don't need to include them twice. You only need to do it once. So now what we need to do is we're going to be taking plus or minus, and we need to set up every single possible combination of our factors of P over Q. So I'm going to leave myself a lot of space here, and I just do plus or minus. And then we just keep on listening. So we have 18 over 4, comma, plus or minus 18 over 2, comma, plus or minus 18 over 1, comma, plus or minus 9 over 4, comma, plus or minus 9 over 2, comma, plus or minus 9 over 1, comma, plus or minus 6 over 4, comma, plus or minus 6 over 2, comma, plus or minus 6 over 1, comma, plus or minus 3 over 4, comma, plus or minus 3 over 2, comma, plus or minus 3 over 1. And I'm running out of space, so I'll continue on. So I'll do plus or minus, when I'm done with the 3's. So I'll do 2 over 4, comma, plus or minus 2 over 2, comma, plus or minus 2 over 1, comma, plus or minus 1 over 4, comma, plus or minus 1 over 2, comma, plus or minus 1. All right, so you can see there's a lot of possible rational zeros, but this is a polynomial that's only to the third degree, and we do not have that many zeros. And a lot of these are redundant, and we're going to go and take a look at them and see if we do have some redundancy. So I'll just kind of rewrite these. And I wanted to write them all out with plus or minus, but you don't have to. If I just write plus or minus, I just need to make sure I understand that they're all going to be plus or minus. So 18 over 4, that can't be simplified, but we'll leave it as 18 over 4. 18 over 2, we can just leave as 9. Then we have 18. 9 over 4 cannot be reduced. I don't know why I'm done with plus or minus. So 9 over 4. Then we have 9 over 2. 9 over 1, we can just simplify as 9. 6 over 4, we can simplify into 3 halves. 6 over 2, we can simplify into 3. 6 over 1, we'll just write as 6. Then 3/4. 3 halves, you can see, we already have 3 halves, right? So I don't need to include it again. And I already have 3, so I'm not going to include that again. 2/4, we can rewrite that as 1/2. 2 over 2, we can rewrite as 1. 2 over 1, which would be 2. Then we have 1/4. And then 1/2 we already occurred, and 1 already occurred. So really, I simplified my P over Q a lot by eliminating some of these that are redundant. And now I really only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 factors. 14, I'm sorry, possible rational zeros. But remember, they're all plus or minus. So there's really 28 of them. Now, there's two ways you can go ahead and find the remaining zeros. First way is use graphing technology, which I prefer, to be able to determine one of your zeros. If you don't, you're going to have to apply synthetic division for every single zero until you find an exact zeros, until you do synthetic division and get a remainder. So usually the best zeros to do this are with 1. And I would always tell every student to start with 1 and -1 and see if those are going to be zeros. So just do synthetic division with those, because synthetic division we can do pretty quickly. All right, so you bring down the 4. Since it has a remainder, that is not a 0, right? Positive 1 is not a 0. Then we'll do this again. 4. So therefore, 1 or -1 is not going to be a 0. All right, so now let's look at what's the next idea. What would be the next number you would like to choose to do synthetic division if you don't have a graphing calculator? 2, right? Now, I'm going to save you some time because I know 2 is not a 0. The next one, though, I would go into would be 3. So let's try 3 or negative 3. But yes, if you don't have a graphing calculator, unfortunately, you would probably have to do 2. But it doesn't take too long. It takes 10 seconds to do this with there. But a graphing calculator, you can graph it and immediately see what the 0 is. 19 times 3, that's going to be 19. No, that's going to be 19. I'm losing my mind. It's going to be 38, which will be 57. Yes? Maybe? So that will be 46. 46, that's going to be 92, which would be 138. Either way, I know I'm going to have a remainder. Let's do negative 3. Bring down the 4. 4 times negative 3 is a negative 12. That becomes a negative 5. That becomes a positive 15. This becomes a negative 4. That's not right. What did I say? I thought I said 3. Oh, it was negative 2. You're right. So guess what? 3 doesn't work, right? So let's go to the 2's. Dang, I thought it was 2. All right, so we know 2 is going to work, right? Or negative 2 is going to work. So let's save ourselves some time, and let's just do negative 2. Because I graphed it before, and I was able to determine that negative 2. But if you didn't, you would just work with the easiest number, 1, then go to 2, then go to 3. But I'm sorry, I kind of wasted your time with the 3's. So let's do this. So I bring down the 4. 4 times that, that's going to be negative 8. Negative 1, 2. This becomes negative 9. Positive 18, 0. So therefore, you have a remainder. Constant, linear, quadratic. So now I know that this is now going to be my factor, right? So I can write that as 4x squared minus x minus 9. I know that times, if that's a 0, then that's a factor, right? Yes? Remember the division algorithm? You take your divisor and your quotient, those two multiply to give you your polynomial. But they're asking us is, once you determine the rational zero test, now tell me what are all the zeros? Well, I found my 0. I wrote it as a factor. I divided it into there by using synthetic division, and I found the quotient factor. Now what I need to do is find the 0. So I set this equal to 0. And now I set both of them. Since there's a product is equal to 0, I can say 4x squared minus x minus 9 equals 0. And x plus 2 equals 0. Well, we already know x equals negative 2 is a 0 because we proved it. Now I need to factor this. And again, you notice we come back to factoring. So I need to determine this. So that would be a negative 36. What two numbers multiply to give you negative 36? Add to give you a positive 1. I don't think that's going to work, is it? I don't think that's going to work. Negative 36, add to 1, right? Add to give you a negative 1, because you only have, you have 6 times 6. You have 12 and 3. That's not going to work. So how else can you solve for this, right? This is now, these aren't rational zeros anymore. But so we have negative 2. That was a part of your rational zero test, right? Plus or minus negative 2. So how else are we going to figure out what this is? Well, another way, if you don't have your calculator, you have 4x squared minus x minus 9. That is a quadratic in the form of ax squared plus bx plus c. And we know that all quadratics can be in the form of opposite of b plus or minus the square root of b squared minus 4 times a times c. All over 2a, and remember that equals your x-intercepts. So we could solve it this way and see what is going to come out of it. So if I do opposite of b, that's going to be a positive 1 plus or minus the square root of 1 squared minus 4 times a, which is 4 times c, which is negative 9, divided by 2 times 4. Well, when simplifying this, that equals x. We have 1 plus or minus the square root, and that's going to be 1 plus, let's do, that's going to be 16. Oh no, let's do 4 times 9 would be 36. Times 4 would be 72, so that'd be 144. Yep, and then plus 1, so that's going to be 145 divided by 8 equals x. So it looks like I know that the square root of 144 is 12, so this is going to be a decimal, right? So therefore, my zeros, I have 2 zeros locked away in here, which are going to be decimal approximations. And then I have another 0, x equals -2. So I'm not going to have anything nice. These would be decimal approximated if I needed to. But therefore, that's my other 0 as well. OK? And there you go. So yeah, those would be the zeros. And remember, all this says is